Good evening, and welcome to another episode of Maths in an Empty Classroom with me, Mr. Southern. This evening we're looking at exponential rates of change, and we're looking at a word problem, initially one to do with the value of a motorbike. And that motorbike's value is being modelled by the exponential equation v for value equals a e to the negative kt. And we're told in the question that a and k are both constants, which just means that they're numbers. But what I just want to look at to begin with is the fact that this is a negative here. So k is a number. At the moment I'm not worried what number that is, but the fact that it's negative here, if you think back to when we did sketching exponential graphs, it means that rather than being one of these exponential graphs, because of the negative, it's going to be one that's shaped like that. And that's important because it should make sense to you that, okay, this kind of curve would be used to model something that is decreasing. And a motorbike we expect to decrease in value from new. Okay. Right, so we're given some information in the question. We're told that the motorbike is bought new for £6,000. That tells us the fact that it's new means it's at the start of our model, which means that t equals 0. So when t equals 0, we're told that v is 6,000. And we can use that information to work out part A, which tells us, or asks us to find the value of A. So, part A, using the equation v, we know is 6,000, equals a e to the negative k times by 0, which is our value of t, because it's the start, it's when it's new, it's our initial value. K is a number, times it by 0, it's still going to be 0. E to the power of 0, anything to the power of 0 is 1. So what I really have here is 6,000 is a times 1, which means that a is 6,000. The reason for the wording of the question right down is that once you become fluent with these, you'll be able to see, oh, okay, well, if t is 0, this bit's going to go to 1, so a is the same as v initially. Right then, part B is asking us to find the value of k, giving your answer to 3 significant figures. Now for this we're going to need to use the other bit of information we were given in the question, which is that after 3 years the value of the motorbike is 4,900. So it's giving us another value of t and another value of v, and we're going to use that to find out the value, the number that k is the value of k. So, part B, using this equation here, v equals a e to the negative kt, I now know that a is 6,000, and because it's a constant, it's not changing, so it's still 6,000 in part B of the question. So I can now say that 4,900 equals 6,000 e to the negative k times by 3, because 3 is my value of t for this value of v. What I'm going to do now is I'm going to solve this equation to find the value of k. So you can see I've got an e in here, so I'm going to use the inverse function of e, which is ln, but to do that I first of all have to have e on its own. So dividing by 6,000 on both sides, I'm just going to simplify that to 49 over 60, and that's going to equal e to the negative 3k. I've just written minus k times 3 as negative 3k. Now we've got e on its own, we can ln. So ln 49 over 60 is going to equal negative 3k, which means that k is going to equal negative 1/3 ln 49 over 60. And I'm asked in the question for that value of k to 3 significant figures. So all I do now is I type into my calculator ln of 49 over 60 and divide it by negative 3, and it comes out as 0.0675 to 3 significant figures. Because I've now worked out that value of k, I'm allowed to use that value of k for the rest of the question. So what I'm going to do is I'm going to go back to the top and I'm going to say, right, okay, V equals AE to the negative KT, but I know that A is 6,000 and I know that K is 0.0675. So for the rest of the question, I'm going to be using this formula here. V equals 6,000 e to the negative 0.0675. And I'm going to clear all this off now so that I've got space to do the next bit, because the important bits I've retained for the rest of the question. Now, part C is saying, using your answers to part A and B, find the value of the motorbike after 10 years to the nearest pound. Well, that's straightforward. 10 years, t is going to equal 10. So I simply substitute t equals 10 into the formula using the values of A and K that I know are constants and aren't going to change. So 6,000 times by e to the power of negative 0.0675 times by 10 comes out as 3,054.938, and I'm asked for the nearest pound, so the value is £3,055, and that is to the nearest pound. So given a value of t, sub it in, find the value of b. Part II says find the time when it's worth 1/3 of its initial value. Okay, so 1/3 of its initial value, well, we worked out that its initial value was 6,000. So 1/3 of that is 2,000. So I'm going to set that equal to the formula 6,000 e to the negative 0.0675t, and solve to find t. This is going to look very similar to when we solved to find k in part B. So dividing by the 6,000 to start off with, I'm going to simplify that to 1/3, e to the negative 0.0675t. I've now isolated e, which means I can ln. So ln of 1/3 is negative 0.0675t. So to find out the value of t, I'm just going to divide ln of 1/3 by negative 0.0675. And that is going to come out as a number. Ln of 1/3 divided by negative 0.0675 as 16.275. So t equals 16.3 years to 3 significant figures. So that is the time after which the bike is worth 1/3 of its original value. So part I, we're given a value of t and asked to find v. II, we're given a value of v and asked to find t. So using the equation we've got for two different purposes. Right, part D is asking us to sketch the graph for this equation here. So part D. Now, remembering from the sketching exponential functions, that what are the three things that I'm interested in when I'm sketching an exponential? I'm interested in the shape, the intercept, and the asymptote. So the shape we talked about at the beginning is going to be an e to the negative t shape. My intercept on this axis here, which is my v axis, is going to be the initial value when t is 0. So it's 6,000. And if you remember, how do you work out the asymptote? Well, the e bit can't be 0. So we say, okay, well, what if the e bit was 0? Well, the overall function would be 0. So what that actually means is that the asymptote is v equals 0. So the value of the bike is decreasing exponentially, but it's never quite going to be completely worthless. So there you are. Shape, intercept, asymptote. Job done. Notice, and this is very, very important, that I do not have a negative part of my x-axis, but it's t-axis, and it's because it's a t-axis that I don't have a negative, because you cannot have a negative time. Okay. Final part, the rate at which the value of the bike is decreasing. Now, what I want you to get into the mindset of is that whenever you see the word rate, you interpret that as differentiate. Rate of change, differentiation, it's all about rate of change. Now, what I'm going to do here to find the rate of change is I'm going to differentiate v with respect to t. So it's going to give me dv dt. Now when we differentiate e's, you'll remember that the e bit stays the same and you multiply by the coefficient of t here. So all we're going to get is we're going to get negative 0.0675 times by 6000e, and the power will stay the same, negative 0.0675t. So let's find out that value at the beginning there. That is 405, so it's negative 405 e to the power of 0.0675t. And this is telling me the rate of change of the value of the bike. I'm asked for this rate when t is 4. So if t is 4, I substitute 4 into my value for dv dt. So negative 405 e to the power of negative 0.0675 times 4. So let's do that now. E to the power of negative 0.0675 times 4, times that by 405, and it comes out as negative 309.16. Now, I'm happy with that. It's come out negative because it's decreasing. So what I need to do to give my answer to the nearest pound is to state that it's decreasing by £309 per year, and that's to the nearest pound as requested in the question. So key points, you see the word rate, you interpret that as differentiate. We differentiate our equation for v, and then the rate at which it's decreasing, we expect a negative value here. And remembering, of course, the process for differentiating exponentials in this case is to multiply by the coefficient, this number here. So negative 0.0675 times by 6000e, and this power bit here did not change. That's example 1. Join me in the next video where we'll go through example 2. I'll see you then.